start the live stream.
Amazing.
Okay, there we go. We are live. Great stuff. Well, thank you everybody for joining, and what is always going to be a fun time when we have a superstar of the group and of the Azure world waiting to give us some latest updates on something absolutely incredible, I'm sure. Awesome, you told me on LinkedIn. Why do we use LinkedIn to chat? I don't understand.
Because you messaged me happy birthday on LinkedIn and we just kind of went with it. But...
There we go. So we are the people who use LinkedIn for inappropriate things, but never mind. David has been an absolute stalwart of the group, having been in the audience and on the stage, and being the only person I know of to have been censored out of a live stream by Microsoft. I mean, what better way to introduce you?
Perennially censored.
Yeah, absolutely. So thank you everyone for joining. I'm going to just hand straight over to David and let him sort out what he wants to do.
Yeah, cool. So this is super bizarre because I can't even see if there's anyone else in this meeting right now. I can literally see me, you, and an invite. So I wonder if there's a Q&A, share conversation. I don't even know if we can you see anyone? Is anyone here?
Yeah, there's attendees, and we are live.
Amazing.
4:37, 30, going up quite quickly. So.
Perfect. So I'm just gonna kill a little bit of time and have a quick drink while I share my screen, and we're gonna see if this works.
There's been really smooth tech start to this, hasn't it?
Yeah. So definitely all the links for me to join this chat didn't work. I do have a lot of rum to keep it in the spirit of user groups in a pub. And now let's see if we're going to get this work. Open the share tray. This is an experience. Let's see. Maybe that. Do we see a slide deck? I think we might see a slide deck.
Yeah, I got it. Right,
Amazing.
so I can put that there, and I can also put you on the side if you like.
Yeah, why not? I'll stare down everyone. It's fine. Cool. So what I'm really here to talk to you about isn't the horrific experience of joining a Microsoft Teams broadcast via a dubious link. I'm here to talk about Azure Static Web Apps because they're totally awesome and I've been using them loads recently. So I'll introduce myself first. I'm an independent software consultant based in London and the UK. I work for myself, which in the 2020 world of coronavirus means I sit in my home office and rage tweet at the internet. But mostly I've taken roles mentoring developers, doing strategic work for big UK dot-coms. I've had really pretentious job titles like head of engineering, chief technical architect, head principal engineer, companies like Just Giving, Tradeline, Just Eat, like all the .NET shops around London. Which all sounds a lot fancier than it really is, because what I really do is I just love making things, and I really love the people that make things, and I try and spend a lot of my time helping them do that. My one plug is I've also written a couple of kids' books about programming, Get Coding 1 or 2, available at all regional bookstores. But enough about me. And more about this topically appropriate thing. So over the last 3 months or so, I've been building a lot of experimental software on the web. So when I say experimental, I mean deliberately stupid things, silly things, fun things, things that bring me a little bit of joy. And throughout it, I've wrangled with different ways to host, and we're going to use the big air quotes here, modern web content. So I've been through the ringer of hosting things on services like Glitch for its interactivity, Heroku to get Node running, Azure App Services to run Node processes and .NET Core processes. But each time it felt like effort, like a lot of effort, and actually quite a lot of cost. Not in the you're a big corporation building websites cost, but in the if it's you and your credit card cost, actually quite a lot of cost. Really just to put a really small thing on the internet, just to get web pages up. So everything was somehow a compromise, either in effort, complexity, or functionality. So when Microsoft put out the beta of static web apps a couple of months ago, I was pretty keen to try them out. And there's a lot of companies in this space. You've got Vercel, formerly Zit now. You've got, I don't know, there's a whole bunch of like static web hosts trying to move on this space. And obviously, firstly, this is the Azure user group. But secondly, most of the stuff that I run is on Azure. So it's really, really nice to have something in the same place. So they're still in beta. The docs are really quite light and the paint is very literally dripping wet. But they're a really great way to build web applications in 2020, I think, and they cost next to nothing to run. In fact, right now they are free to run because they're in preview. So what I want to do is I want to talk you through why they're awesome, how to set them up, and how to customize them for different programming languages, along with touching on how to deal with local development and debugging, because as is the way with much of the promotional stuff around this, it doesn't really talk about that scenario too much. It's all very important. So we need to really talk about serverless. So this is the oft-repeated joke, and it's a bit trite. Oh, the cloud is just other people's computers, and serverless, to extend that analogy, is just someone else's application server, ultimately. So while there is some truth to it, underneath the cloud vendors somewhere is a computer, but it certainly doesn't even look remotely like you think it does. Right? So imagine your computer. Look at your computer on your desk or under your desk if you've got a desktop. So when did you last dunk your desktop computer into the sea looking like this, right? Like, while the cloud is someone else's computer and serverless is someone else's server, it's also someone else's hardware abstraction and management team with SLA to satisfy. And it's operated by someone else's specialist. And both the cloud and serverless make your life a lot easier by making computers and servers somebody else's problem. So in 2020, with platforms like Netlify and Vercel taking the PaaS abstractions to the natural conclusion and iterating products on top, it's really actually great to see Microsoft, who for years have had really great PaaS offerings in Azure, start to aim their sights at an easy to use and accessible offering for the average web dev. It's important. So once you remove the stupid sounding Jamstack acronym, which is what JavaScript and markup and APIs who cares, shipping HTML and JavaScript web apps that rely on APIs for interactivity is a really common scenario. And the more people building low-friction tools in this space, the better. So let's start by looking at how Azure Static Web Apps work in a regular Jamstack, and then we'll see how they're a little bit more magic. So first, what exactly are Azure Static Web Apps? So Azure Static Web Apps is a currently beta new hosting option in the Azure Web Apps family of products. We're going to use the word web apps. They're an easy way to quickly host some static files, so HTML and JavaScript flat files, on a URL, and have all of the scaling and content distribution taken care of for you. So they work by connecting a repository in GitHub to the Azure Portal's Static Web Apps product, and then the portal configures your repository for continuous delivery. It's like a really super slick end-to-end experience. So what we're going to start off by doing is walking through what that actually looks like. And we're going to do it in slides because I absolutely do not trust doing a live demo because my internet's cut out 4 times. So when you're creating your first static web app, what we're going to do is we're going to start off by creating a new repository on GitHub. Now, I imagine at this point in time, everyone is familiar with this single GitHub screen. And you fill in your repository name, you probably choose the MIT license, and kind of hit OK. We're going to add a Node.js git ignore as well, because even though we're building static web apps, there's some JavaScript tooling underneath for better apps. Then, still in the browser, we're just going to create a new file. We're going to add an index.html file to our brand new repository. And is it not beautiful? Look at that, some gorgeous HTML 5 boilerplate. They're so static. It's beautiful. This is all we've got, right? So it's perfect. I love it. So to the Azure portal. Sorry, this is just my own lockdown wishful thinking. I've been stuck in this room for a very long time. What I really meant is this one. So once you've successfully run the Takeshi's Castle-style gauntlet of Azure Dashboard Federated Identity login pages, what you need to do is you need to search for static web apps, and you'll end up on this creation screen. So what we do is, by hopping across the Azure portal, we add our new repository as a static site. The cool thing about this process is that actually the Azure portal configures all the GitHub actions and the GitHub secrets inside of your repository. So it does the security key dance where it adds security keys and secrets to facilitate the deployment. So we're just giving the new site a resource group, or creating one if you haven't used Azure before. And then what we're going to do is we're going to select our GitHub repository. And then once we hit review and create, we'll see our final configuration. So actually, since I took this screenshot maybe 3 weeks ago, there's now like an extra bit that appears underneath here, which asks you to pick one of the default templates. And that depends on the static site framework that they expect you to be using, but we're going to go through it in its raw glory right now. So you end up with this preview page where it describes the resource group. It's just anything, right? So a name, test site, I'm putting it in West Europe, SKU, the really important bit, it's free. And the repository that I'm connecting this thing to. You'll also notice that I've set up an app location of slash and an API location of API. We're going to talk about that later. So once we've created our app and the process is completed, it takes about 20 or 30 seconds. It's confusedly messages the deployment being complete, but I think that what that really means is they created your static site. You can now click go to resource and you can go and see your web app. So cool, the most dramatic thing we could ever have written. You're online. So the cool thing here is I legitimately think this is probably the easiest way to get HTML onto the internet today in 2020, with the exception of Azure Federated Identity. It's like the boss monster between nice, easy to use tools and everything else. So what did that actually do? Because all I really did is made a HTML file and clicked 4 buttons. Really? Like I didn't set up anything, I didn't configure anything. So if we refresh our GitHub pages now, what we're going to do is we're going to see that the Azure create process, when you give it permission to commit to your repositories, it actually used them. So when you created your static web app in the Azure portal, it did 2 things. It created a build script that it committed to your repository, and it added a deployment secret to your repository settings. So the build script gets generated. It's relatively low, but you're not going to actually have to touch it yourself. What it does is it configures GitHub Actions to build and push your code every single time you commit your master branch. And it also configures special preview environments when you open pull requests, so you can preview changes to a web app without actually having to barrel roll into master or main. So let's get technical. So the build script is modified each time. The build script is modified each time you reference the deployment secret that is generated by your Azure portal. So you'll notice that the secret key lines up with the key that's added to your repository. So if you look here on line 25, there's like an API token for static web apps, an API token Lex. And then in our secrets section, in our repository settings, the Azure create process has committed that secret, so you'll never see it. So is this just web hosting? I mean, what makes this so special? So far, this is simple and kind of also entirely unexciting. And that's part of what makes it so special, actually. What makes Azure Static Web Apps so special is their seamless integration with Azure Functions. So traditionally, if you wanted to add some interactivity to a static web application, what you would normally have to do, and if you Google this, you have to stand up an API somewhere, and then make it accessible, configure your load balancers, or set up some functions somewhere, or Lambda functions on AWS. What Static Web Apps does is it pulls these 2 things together and allows you to define both Azure Static Web Apps, the HTML flat file serving portion, along with some Azure functions that your web app is going to call in exactly the same repository. So this is really, really cool because you still don't have a server that you have to maintain anymore, but you can run server-side code. And it's especially excellent because the server-side code that your application depends on is versioned and deployed together with the code that depends on it. So you still have a cohesive web application here. Looks and smells like a server-side app, really, but has all of the positive characteristics of a static content distributed flat file thing. You know, the infinite scale, can't crash, no web server app. So you can kind of get to have your cake and eat it, and that's actually really, really fun. So we're going to do it. Let's add an API to the static app. So by default, the configuration that was generated for your application expects to find an Azure Functions app in the /API directory. We didn't fill that in the template, it was just the default. So what we're going to do is we're going to use npm and the Azure Functions SDK to create. So at the time of writing, the functions runtime only supports up to Node 12, which is the latest long-term support version of Node, and it's updated tracking that version. So you're going to need to have Node installed in your path for the next part of this tutorial to work. First, we're just going to check out our repository. That's what it looked like on my disk when I took screenshots of it last night. So there's nothing. You can see our index.html file and all the detritus that GitHub generated. So then we need to make sure that we have the Azure Functions core tools, that's not installed, which you can do at the command line by typing the wonderfully long-winded npm install -g Azure Functions core tools @3. And actually, the Azure Function tools are really, really good. They give you like a full simulated environment, which I believe is the exact same code that's run in the Azure Functions runtime in the cloud. So local dev here looks and feels exactly like it does when you're running production. I honestly had like a really, really good time in general. So now we have to run a few commands to create an Azure Functions app. So what this does is it generates a default JavaScript to Node Functions app in our API directory, and we need to create a function for our web app to call. So we're going to do that with the final command here, called func new. What this does, this adds a new function called hello world into API directory. So all we're going to do is, as you can see, switch directory to the API directory. We're going to type the wonderfully forgettable func init worker runtime equals node language equals JavaScript, and then func new template HTTP trigger. That means it's going to configure the function we're generating to run when a HTTP request comes in, rather than a message or whatever else. I don't know what else can trigger it. Probably a timer. And you give it a name, hello world. So then a function appears, right? These are the bindings that get generated, and they tell Azure what to do with your code. So the SDK also generates some code that actually runs. So you end up with the API folder and all this stuff here. And this is what the default Node JavaScript template looks like. All it does is it returns a string. And if you add the query string or post body property name, it says hello to you specifically. Super, super trivial. Every Azure function entry point pretty much looks like this. So we're going to edit our HTML now. So we're going to use the browser's fetch API to call /API/hello world. Azure Static Web Apps will make our functions available following their pattern. So if we push these changes to Git and wait a minute or two, our deployment will run. And then when we load our web page, you can see what we're doing here is we're calling hello world, we're grabbing the response from that API as text, and we're just logging it out to the console. Right? And here's one I made earlier. If I hit F5 on that, you see we get that this HTTP triggered function executed successfully. That's the message, the default. Like, how awesome is that? It's a server-side API without a server from the same directory that you've got basically a static file. If you open up the Azure portal again and click functions in the UI, you'll see your hello world function now shows up. So this is the static web app thing, and you'll notice they're kind of integrated Azure functions into the settings area, bizarrely named, but we'll go with it. You can't do anything with your function here, so if you've ever used Azure functions before, used to being able to kind of see the functions text and type it, like, this is all driven from the repository, so don't expect any kind of editability. But it's cool, you can see all the functions your app depends on, just literally zero effort. I love it. But can I run it locally? And this is always the thing I always think whenever some shiny new Azure thing is announced, like, cool, but like, how do I test this? How do I dev against this? So Microsoft recommends using the npm package live server to run the static portion of your app for deployment and development, which you can just do by typing npx live-server from the root of your repository. So like live server is pretty cool. All it is some bundled up node dependencies that just like a hot module reloading the web server. But actually, if we look really carefully at the screenshot, like what's going on here? This looks wrong, right? So you'll notice the stuff that's written in the console looks like, I don't know, CSS. Right, so what's happening is Live Server is treating the /API directory as if it were content. And it's serving an index page locally, which really isn't what we wanted it to do. So to make this run, like we would on production, we're also going to need to give the Azure Functions runtime. We're going to need to run the Azure Functions runtime and tell Live Server that what we want to do is proxy any calls from /API across to our running Azure Functions runtime. It sounds like a mouthful, but we're going to see how simple it is. So there's a couple of things we have to do. We have to run our functions runtime locally, and in another console tab, what we're going to do is we're going to start off Live Server, this time telling it to proxy calls to /API. So you do that by typing npx live server -- proxy, and then we give it the address that the functions runtime is running on. So that's just localhost on 7071 /API. This is all kind of a mouthful, and it kind of makes me feel uncomfortable having this ephemeral configuration. But now, if we visit our localhost on 8080, the live server default port, you can see we have exactly the same behavior as we did in Azure. So it's we see that live reload is enabled from live server, and then you see console output of us calling our Azure Functions API. So this is great, but it really makes me feel uncomfortable. It seems a little bit fiddly for local development, right? And if you open your root directory in Visual Studio, it will hint that it has a browser extension support for debugging and development. But what I really like to do is I like to capture all this stuff inside my repository. So anyone that you're working with our team or download your stuff as a demo can run these sites from the command line really, really trivially. So we're going to add some useful stuff. Right? I don't know about you, but I constantly forget things. Terrible. So I want to capture all this weird command line voodoo in some npm script, so I never have to remember it ever again. I can just copy a file for the rest of my career. Because, so what we're going to do is in our API's package JSON file, we're going to add 2 useful npm tasks. What this means is that we can call npm run start on the API directory and have our functions runtime start up. So we're adding this pre-start task, which makes sure the functions extension is installed. And we're going to add the start task, which just starts the Azure Functions runtime. We're then also going to add a package JSON to the root of our repository so we can capture all of our live server related commands in one place. So from a command prompt, we do an npm init, and then you just, like everybody else does with Node, hammer the enter key as many times as you can. Right? And you end up with something that looks like this. This is like completely default what npm init does. And now what we're going to do is we're going to add a couple of packages and scripts to make our lives easier here. We're going to need the npm run all package. So firstly, let's add that and say that it's a dev dependency. And then we're going to add a few startup scripts. What we're doing is we're setting up a dev::API and dev::server task, and then a start task to call both of those to automate the command line work that we just had to incant above. That's kind of all that magic stuff. But now it means that for local development, when you pull this repository, you can just type npm run start. And what it does is it first calls that start task, which in parallel, which is what the npm run all task does, will run npm run start in the API directory and invoke our live server with our proxy configuration. And with these 2 by 3 startup tasks, the environment here works exactly how it would on Azure, without us having to remember any of that stuff. And we can see our changes in a hot reload web server while we work. So this is probably like an order of magnitude more fiddly than creating a new MVC app using Visual Studio and committing it. You have to actually do this kind of bitty, kind of annoying piece of work. But as a reward for remembering to add a few build tasks and packages, you actually never have to worry about your application scaling ever again. It's like a trade-off between a little bit of manual work and the risk of getting a call. Right? So what we're going to do is we're going to commit it, and we're going to make sure it all still works on Azure. Oops. So the first time I set this up, it drove me a little bit mad because everything was working. I did all those build scripts, and all of a sudden everything stopped failing, which is really quite annoying. And I guess this is where the paint was dripping a little bit wet on this product. So by adding the root package JSON to make our lives easier, we managed to somehow break something magical in our GitHub Actions deployment pipeline. Oh dear. So we had anchored a giant beast, and its name was Oryx. I don't know if anyone has ever heard of Oryx. If I could see all your faces in the room, I'd be looking to try and see you all nodding or shaking your heads furiously. But what Oryx is Microsoft's build. So if we dig around in the logs, what you'll see is something called Oryx can't find a build script, and it basically doesn't know what to do with itself. You'll see this message here: error, could not find either build or build Azure node under scripts in package JSON, couldn't find a value, like a whole lot of stuff, right? And I'm sitting there racking my brains thinking, well, this was kind of working before. So as it turns out, the cleverness that's baked into the Azure Static Web Apps is a tool called Oryx, and it's expecting frameworks that it understands. And what it's doing is it's running some language detection heuristics and looking for specific files. So what just happened is it found our package JSON in the root of our repository. And it presumed that we were going to be specifying our own build jobs because we provided a package JSON file. And it's like, I know what to do with Node. This isn't a static site anymore. Let me call build. But then it gave up because we didn't provide one. It just doesn't know what to do. And I'm honestly, I'm not going to lie, I lost a couple of hours working out that I could scroll down the logs in GitHub Actions. I know it sounds ridiculous. They're all kind of folded up into little tabs. And I was staring at my computer for just to see that very informative error message. So the easiest way I found to be able to use the Node tooling and still play nicely with Azure's automated deployment engine is to do two things. The first thing we do is we're going to pick up our static assets and we're going to move them into a directory called app. What that means is our root directory will now look like this screenshot. And then we're going to update our deployment scripts to reflect it. So we need to edit the YAML file that Azure generated in the .github/workflows directory. This might sound scary, but we're only really changing one thing. In the jobs section on roughly line 30 of the currently generated sample, there are 3 configuration settings that you can see here: a app location, API location, and app artifact location. All we really need to do here is update the app location to read app. And then finally, we need to update the NPM scripts that we added to make sure Live Server serves our app from that correct directory. So in our root package JSON, we're just going to add app to our dev server build task as the command line. We're also now going to add an empty task called build::Azure. It's not going to do anything. We're just going to put it there so Oryx doesn't get ahead of us. So in total, we've only changed a few files really, really simply. You might want to run your npm run start test again now just to make sure everything still works locally. I mean, it definitely does. And commit your code and push it to GitHub if you're following along at home, which I hope you're not, because I'm way too fast. But like, wonderful, we get a green tick, everything is totally working. So here's the really cool bit, I suppose. So now we've configured a build task and know where we configure an app artifact location, we can pretty much do anything we want. Right, so you want to use Jest, that absolutely works. You can do an npm install for Jest and you can write unit tests. You can add unit tests to a part of your build process as a pre-build, as a pre-deployment step. You want to use something awesome like Wallaby, you can do that too. Why not both? You just need to npm install the thing you want, and you can absolutely test the JavaScript in both your static site and your API. You can install Webpack and you can produce different bundled outputs if you like. You can use Svelte if that's your thing. Really anything. And Microsoft's tooling will make sure to host and scale both your API and your web app. So I've been experimenting recently with running a tool called Snowpack, which replaces Live Server, and it allows you to do like native TypeScript web apps that can reference node modules, and it just works. It seems brilliant. So my standard dev loadout for working with static web apps is this. So I had a few dev dependencies. I had Jest and the Jest CLI, Live Server and Playwright for browser testing, and I put in Babel so that I can run Jest tests with the latest kind of TypeScript, JavaScript features. And I also use this Babel preset env package, which basically says compile my JavaScript for whatever the current version node I have installed is. So you can kind of use all the modern conveniences and language features of JavaScript without being stuck in 2012. I also tend to throw in a default Wallaby.js configuration file in my root. It's a continuous test runner, which is really, really similar to Ncrunch, but for JavaScript and TypeScript. So I suppose I've spent a lot of time crawling my way back to the kind of productivity I have in C# Visual Studio with Ncrunch in this somewhat more typeless environment. Speaking of types. So yeah, the Azure Functions runtime totally supports TypeScript, which is really cool. When you create your API, what you need to do is function it work at runtime with the language of TypeScript instead of JavaScript. And the API that's generated will be TypeScript, and it's really that simple. Like if you switch it down there, you'll notice there's a couple of little type definitions in there. What it does is it configures the TypeScript compiler and it puts some binding files in place so that when the functions run, you get source swaps generated, and it's kind of natural and it uses Webpack and I believe. Yeah, so it creates an extra JSON metadata and a compiled dist directory, and that's built on as part of the GitHub actions. You don't really have to write this up. Let's go wild. How about C#? Well, you can actually totally use C# and .NET Core too. So if you function it using the worker.net, the SDK will generate C# function code that works in exactly the same way as its JavaScript and TypeScript equivalents. You can literally run a static web app with an auto-scale .NET Core API backend. Kind of anything that the Azure Functions runtime supports is valid here. So Python too, and actually I just saw a really interesting series of posts, I forget who was posting, using their new language provider feature. Someone was writing an Azure function in COBOL, I believe, and providing a host service for it. Like all this stuff really just works out of the box. And I really think this is really super awesome. So I kind of hope by splitting this out into tiny steps and explaining how the GitHub Actions build interacts with both the functions runtime and the Oryx development deployment engine that drives Azure Static Web Apps. It's giving you a little bit of inspiration for the kinds of trivially scalable web applications that you can build today, but for practically nothing for free. Like if you're a C# shop, that's a hard thing to say, and a little out of your comfort zone away from ASP.NET MVC, why not use static web as part of the build process to generate static web apps that use C# and are driven by C# and a .NET Core API? Only familiar with Python, but you can use Pelican or Lecter to do the same thing. I could probably do an entire extra session on using C# to power these build tasks, but it works just as you could imagine, with Oryx finding and building your C# code, just so long as you produce artifacts in the right locations, and you can really have your code generate anything. The Oryx build process that sits behind this is flexible and provides plenty of hooks to customize the behavior between repository calling and your site getting served and scaled. These kind of powerful serverless abstractions let us do a lot more with a lot less. And without the stress of worrying about outages, downtime, or scaling, you can actually get from zero to working in Azure static sites. And I would probably say about 10 minutes. And then once you've done it one time, I legitimately think this is one of the best ways to host content on the internet today. Like it supports stuff like custom domain binding. Basically anything you imagine should work kind of really does. So that's kind of the end of my slide deck. I'm going to open up something now to show a sneak preview of something I've been working on for the C# devs. So if I can just find static sites. think it's on GitHub. I said I wasn't going to do a live demo. Do something silly. So I kind of this is now my script is gone. So opening Visual Studio and you can see it in. So one of the things I thought when I first started playing with this is, wouldn't it be really, really cool if I could just do all this driven from a C# web app? On Visual Studio, it's going to have to be made very, very big. So what I've got here is I kind of worked out the smallest possible thing you can do to make this massive. To use a C# console app to generate all this kind of static content. And it's kind of this. See my breakpoints where I was kind of working this out. So I basically ended up writing this C# program and running it in the GitHub Actions runtime to work out what environment variables were put into place to balance this stuff and make it all work. What I kind of discovered is that there's these kind of magic environment parameters, destination directory, and input app artifact location. And if you write a console app that reads these variables, what you can actually do is you can just copy a bunch of files to those locations, and the Oryx runtime will detect them and treat them as a static web app. So what I've kind of got over here is I've got a razor page, which is just a layout file from body, a style sheet that's empty, and like an index markdown file. And I think I didn't actually did I get to using those yet? I don't even remember. Oh no, I think in this I just generate an index HTML file. Yeah, so I've got a prototype, which clearly isn't this, that actually uses the Razor engine to pass to basically use Razor as a static site generator. Iterates over the markdown files, and then it detects these from the CI builder on GitHub Actions, works out where the output location needs to be, and then writes a file. There we go, the contents of just hello world. It writes a hello world file into the runner's output directory. So the way that I kind of hooked all this up is a bit wild. Let me kind of explain how this works. So if I open this folder in File Explorer, you'll see kind of the same. Which is a shame. You'll see all the same kind of generated stuff that it relies on for the JavaScript and Node stuff. You've got a git ignore, this .github folder with a workflow, and an Azure static web apps file over here. And what this does is exactly the same thing. It looks for contents that are put in the source directory. Oh god, this was a terrifying thing to do. It expects an API in the API directory, and it looks for this dist directory. So this is all completely normal, nothing weird about that. What happens is that when the GitHub Actions runtime comes and picks this up, it actually detects that there's a .NET app in here.
Dave, sorry, is there a way you could share what you're looking at? Because it seems to be stuck on the slide deck.
Are you stuck on the slide deck? Yes, okay, perfect. Experiment with Teams. Stop sharing. Open share tray. Are you sure you want to share? Yes. Let's go through into the second desktop. Perfect. Okay, this is. Yeah, so this is the whole command line app. I'll just walk you through it again. There's basically these two magic environment variables that the Oryx runtime uses, and combined with this GitHub workflow. Listen here, I can. Wonderful. This is just the same thing that was generated from the slide deck. Runs on Ubuntu. What it does is it detects it's running in CI by the presence of the environmental variable CI and this destination and artifact location. And then just by writing an index HTML file here to the output location, actually Oryx thinks it's run through a static site generator, which is kind of awesome. And you can commit this stuff into this repository as source code, not as a compiled executable. So this thing here literally is just my source, like any other .NET program, a CS proj and a program CS. So the slight hack here is if you take a look in the project file, you can add this target that runs after build. And what this does is it finds the compiled DLL that the build process would run as it gets built in GitHub, and as a post-build action, executes itself, which sounds like a really, really ridiculous thing. But actually, like, it's super awesome. It just means that by building this program, it will build your program, it'll then find any content that you decided to include, and it will invoke it, and then it will publish the output of this program as a static site. So you can literally roll your own Azure static site generator thing from a command line. So yes, I was playing with prototyping using Razor as a view engine to iterate over Markdown files, and the fact that the runtime is flexible enough to let you do that, along with having like a .NET API in the API folder, I think this is actually quite a big deal for the Microsoft space, because this is very, very common with things like Hugo and Jekyll in other ecosystems. But really, I mean, you can kind of see my CS project. I was playing around with static.web as well to see if I could hook this up, and I believe that the new .NET Foundation website actually is a static.web site published to Microsoft Static Sites, to Azure Static Web Apps. Sorry, that brand is horrible. But yeah, like, I think this is super, super awesome, and the fact that you can do it kind of C# first is actually really cool. So yeah, I think this is amazing. We should all try and give it a go, considering it's free at the moment entirely. And yeah, I love it. I think in the 2 months I've been using it, I think I've pushed 10 static sites out, because at the moment you can only put 10 out there, and then you get an API error saying you can't do anything else unless you pay, but no one will let you pay for it yet. So I think if you want to be on the ground floor, please give it a go. Like, it's super, super cool. Now I'm going to stop sharing my screen and hopefully see if there's anyone with any questions.
Okay, cool. Okay. David seems to have dropped off 1 second. We can think about some questions in the meanwhile.
Well, that was certainly one way to stop screen sharing. Perfect.
Those are rather dramatic ends.
The Mikey drop of mic drops.
Drop.
Yeah.
Hang up.
And I'm gone.
Amazing stuff.
Yeah. Okay. So yeah, it's very, very strange talking to an empty wall. I can see people here. We can see the presentation. Cool. No problems. Now I can see yes. The session is frozen. Excellent. I see someone saying OAuth ? And what's the story about securing the API part of the app? Okay, so let's go from the bottom first. So the story about securing the API part of the app. So I believe there's a bunch of reverse proxy magic that happens. That's kind of the thing here. So treat it like a public API that anyone could refer to from the internet. Like, you just got to deal with it like it's that, much like you would for any other public-facing API. So if you would like to roll your own kind of authentication token, API key stuff, you can do that. But at the end of the day, you're still shipping your API keys into a web app, right? So this is the public surface area. It's your backend for front end. So I wouldn't expect you to embed sensitive keys in it, and I would expect you to put anything important maybe behind some other APIs downstream. This is really, really great for that kind of backend to front end pattern that people kind of get into and use, where kind of the people that author the web app are the same as the people that author the API that the web app talks to, because anything else is really, really friction. And I think especially in .NET space, we've had a long history of having lots of .NET teams and some JavaScript heavy teams on the front end, and a lot of friction where the JavaScript devs didn't really have the latitude of the experience to change the APIs, and there's a lot of kind of contention there. Like, I've seen it really cause fracas between teams. So there is no security, but it does set up like CORS headers and things like that. So you should, browser sessions should be protected from like cross-origin posts and that kind of stuff. Okay, so what else we got here? Is there a limit on the site size? That's a really good question. I do not know. I presume the answer is yes, because yeah, I presume the answer is yes. Don't have massive sites. I guess as this thing grows, I would imagine them to more tightly incorporate kind of asset storage, large image galleries and things like that, rather than just being based in the repository. But to all intents and purposes, I've not run up against anything in smaller scenarios of low numbers of hundreds of meg. And you got to remember that, like, obviously once all your code is churning out static sets, there's no like limit on the repository size when it's running through the GitHub Actions publishing pipeline, because that's just GitHub Actions complete a repository. The published artifacts, I imagine, would be smaller. You'll have the duplication associated with static sites, but everything is just kind of HTML, JavaScript, CSS bundles at that. Okay, have I seen any way mentioned of what the pricing structure will look like post beta? That's a really good question. I haven't. No one will tell me. I've been asking very, very nicely. My speculation is what this really is it's clearly Azure storage buckets and Azure functions bundled together on a web interface with some GitHub Actions automation over the top. I would expect the costs to be in line with using those two services unbundled from each other. And those are two of the cheapest things really in Azure, like the consumption plan functions and the CDN content gets like as cheap as it comes, right? So my gut says an order of magnitude cheaper than running a standard Azure web app on Linux is where I would gamble. I don't know anything, so I didn't hear anything from it. Integration with Next.js, yes. By default, there's a Next.js template, and in fact, in the newer creation portal, I believe Next.js is one of the drop-downs, and it will automatically configure like the build scripts and things for you, which is actually pretty awesome. I believe it has support for Svelte, Next, and I want to say Gatsby by default. But really, you can kind of see the pattern, right? Anything that outputs artifacts into the artifacts directory that it expects totally works. Does this early release allow for custom domain names? Also, yes, though it's really, really badly documented. Like the interesting thing about the custom domain names is it asks you to put like a CNAME to www. But actually you can put like www.yoursubdomain.yourdomain.com. It's a little bit precocious, and I find the API backing the portal to add custom domain names is a bit crashy. Mostly because there's a bunch of limitations around it. Once you add a domain name, it's much like other app services. If you delete it from one site and try add it to another, your API calls will just fail, and nobody bothered to write helpful error messages to tell you that. And you kind of just have to wait like 45 minutes, presumably, for some background job to run and clean up domain allocations so they're available to be re-added. But it's a little bit, again, paint dripping wet in the UI there at the moment. The other really freaking annoying thing is you can't rename your main branch, because I tried to rename a bunch of master branches to main and it buggered everything up. And you also can't move your repository once it's connected. So the flip side of that is it literally takes less than a minute to set up a new static site. So what I ended up doing was renaming my branches and just creating a new static site pointing it at it. And you can configure one repository to deploy to multiple static sites. And I just kind of migrated it to another one. But it was a bit annoying when I had to do that. But I know that the teams behind this are being pretty responsive on GitHub to all these kind of niggly frustrations. Yeah, like I lost half an hour, but I'm not gonna really be super upset about it. Any more questions? Could accessibility features be input in the app and its API from the beginning of development? Accessibility features. So, Hamad, I don't know what you mean when you say accessibility features. And to elaborate on that, again, it's an API. So I guess, if you're talking about kind of user accessibility, then yes. But yeah, I don't know. I'm not quite sure what the question is. can you build initial config with an ARM template? Absolutely not at the moment, or at least it's not documented if you can. I tried to poke around with it in the API, and the API stuff isn't quite there yet. I don't see any reason why you're not going to be able to. Like, it's really super trivial. It's like a single templated file. So I can't imagine they're going to shy away from that. What else? Secure. Yes. Live Q&A things. They're really, really weird to be talking to text.
So anything that you think is missing? Any obvious features that you really wish to add to the static apps for now?
Yeah, like, so I really think that the docs around like the .NET support is a little bit lax at the moment. So you can control C# to work, but it's not officially supported. This is clearly targeted at the are they Vercel these days? The Netlify Vercel market segment of like everybody else that's trying to publish a web app. I really I feel that the things that people are going to run up against are the same things people have run up against on any other platforms, like oh, how do I handle user logins? It's a very, very like a common static app thing. And the answer is often delegated authentication or OAuth. But I think until they make those kinds of bits of functionality as easy to consume as just putting the website and the API app, people are going to struggle a little bit. I'd also like to see a little bit more effort going to understanding how storage comes into it, because what I found with a lot of my static apps I've been building is I've ended up using kind of Azure blob storage behind it, and it's really, really nice to kind of have the domains and the APIs, the configuration, and the static sites all in one portal here. Storage is kind of the other bit of the puzzle, and if you look at competing products like Firebase on GCP, like they have a pretty good storage model there, and it's clearly, I wouldn't want to speak on anyone's behalf, but it's clearly the direction of travel this kind of thing has to go on to make it more cohesive as like a low barrier to entry app platform. So I think more like kind of tighter integration around there, creating backing stores that are very, very cheap and generating those API access keys automatically. I think that's kind of the place I'd like to see this go as a product.
All right, that's cool. Good answer, man. So I mean, that's a great talk, dude. Thank you very much. I really appreciate it. Any last questions from anybody in the audience? Give someone 10 seconds. If not, I guess time for an outro from you, Dave.
Yeah, of course. I mean, I don't have much of an outro, other than I'm really sad I can't see all your faces.
That was a bit creepy.
No, come into my study. I've got lots of alcohol. I'd love to see all your faces. But legitimately, like, I've missed everything. It's a bit of a peculiar. This is the first Teams broadcast event I've done. I've done events on Teams where I've seen everyone. I've done events on Zoom where I've seen everyone. I've done events on like fucking Cisco something where I've seen nobody's faces, and it's all a little bit surreal.
Yeah.
Okay, someone's asking a good question about dev, pre-prod, and prod. That is a really good question, and there's a really nice cohesive answer for this. So by default, your master or main branch is tied to production. It's tied to your dub. If you open a pull request against your repository, it makes a whole separate environment as with the name of that pull request. Actually, I don't think it does that by default. Basically, they generate a temporary URL where you can see the changes as your pull requests evolve, which is like super awesome. You can click it, you can browse it, it's amazing. And when you're ready and you're happy with that running instance of the site, you merge it into master, and it becomes prod. So that they really, really put a lot of thought into that really like slick production workflow. Cool.
Right.
Well,
cool
thank you so much for coming, everybody. Hopefully, I'll see you all in the post-apocalypse.
Okay. Good stuff. Thank you very much, Dave.
No problem. I don't know how we